Let's open up the Bourget environment. You can create a new project by going to the pull-down menu under Project and then select New Project. You can navigate to the location where you want to store your project and then give it a name. Let's just call these Cars. Click Create. A window will pop up for the new project, which contains only the project description document. You can open it by clicking on it and then edit the information inside if you want. Let's just leave it as is for now. We can start writing our program by creating a new class, as all Java programs are classes. After you click on New Class, a dialog window will pop up and you are supposed to enter the name of the class that you are creating. In our case, Car is the name of the class that we want to work on. You don't need to worry about the different class types listed here. Just click OK, and we are on our way to create our new class. You see the car icon being created in the Bourget window. If you double click on it, the editor window is open. You can see that the template has already been created for you, which starts with some documentation and then the class header together with the body of the class definition enclosed in a pair of curly braces. This is actually a valid class. It can actually be compiled without any error, although it may not be doing anything meaningful. I'll come back to this template to discuss the general structure of Java programs. For now, let's just replace the body of the class definition with the car example that we have just discussed. The code has already been copied, so I can just do a cut and paste. You can see that this is the same as the program that we have just discussed. Alternatively, you can just open the project that we have prepared for you by selecting Open Project and then open the project that you have downloaded from the course website. You can double click on the car icon to see the source code. Again, this is the same as the program that we have discussed. But how can we run this program? Remember that the main method is the entry point to a Java program, but we have not written a main method yet. Luckily, we have Bourget as our integrated development environment, which would allow us to test the different classes that we have written before putting everything together. Let's first try to compile the program. Good, there's no syntax error. If you right-click on the car icon, you can see a pop-up menu and the two constructors that we have defined for the class car, one with no parameter, the other with one parameter of string type. As I mentioned, constructors allow instances of objects to be created. Let's first select the default constructor with no parameter. You can see a dialog window with a default name given to the instance to be created. In this case, car1. Let's just leave it as is, but if you want to change it to another name, it's okay too. You can see that a red icon is displayed here. This location in the Bourget window is called the object bench. The icon represents an instance of car that we have just created. If you right-click on it, you can see a pop-up menu. You can inspect the internal state or instance variables of the object by selecting Inspect. An inspector window will pop up. You can see that the odometer reading is 0. It is a new car, so it has not traveled anywhere. The name of this car's owner is NoName, which is the default name we provided to owner. Notice that NoName is enclosed in a pair of double quotes. If you go back to the icon, the pop-up menu also shows the three methods that we have defined in the program, namely getOdometer, moveCar, and turnCar. You can select the method that you want to test from the menu. Let's first take a look at the odometer reading by using the getOdometer method. By the way, a method like this, which gets the value of a private instant variable, is often called an accessor or getter method. This is a new car that have just been created, so the odometer reading is 0 as expected. Let's try the moveCar method next, again by right-clicking on the icon and then select moveCar. A window is pop up and we are supposed to enter a value for the parameter dist or the moving distance. How about if we enter 100? You can see that the message NoName's car has moved 100 units is being displayed on the console. If you go back to take a look at the moveCar method, the message was printed out by the io.outputLint statement here. Notice that the method also updated the odometer value. If you look at the value in the inspector window, you can see that odometer now has a value of 100. Let's try the move method again with a value of minus 100. Another similar message is being displayed, but in this case, the car is moved minus 100 units instead of just 100. Oops, you can see from the inspector window that the odometer reading is now 0. If you don't want to break the law, you better fix the program. As I mentioned in the earlier discussion, the problem was created by simply adding this to odometer. Let's fix this by replacing this with the absolute value. This can be done by using the abs method in the math library. This needs to be compiled again, and there's no syntax error. Even for the previous program, no syntax error was fine, but there was semantic error in updating the odometer value. We can create a default object again, move it 100 units. If you open up the inspector window, you can see that the odometer reading is now 100, and move it again by entering minus 100. The message is displayed correctly, and the odometer value has also been updated correctly with a value of 200. Let's create another car by using the constructor with one parameter. I want to create a car for myself, so I'll name this instance TC, and to give the value of owner the character string TC. Notice that I'm putting TC in a pair of double quotes. You see another icon being displayed here. If you inspect its internal states, you can see that this instance is different from the instance created by the default constructor. For my car, the reading of the odometer is 0, and the name of the owner is TC. Let's try to run the move car method for the car TC and enter 100. You can see that the message being displayed now is TC's car being moved 100 units. And the odometer value for the instance TC is now changed to 100, but there's no change to the odometer reading for car 1. Let's try also to run the turn car method for TC and rotate it by 90 degrees. And you can see the message that TC's car is turned 90 degrees. So we have tested both constructors and all the three methods. We can remove the instances by simply select remove. You can see that I have created another class here called car1. In the implementation of the methods move car and turn car in the class car, it simply print out a message on the console. But you may want to perform something more interesting. I'll give you a demonstration on a modified version of this method that you will be able to implement yourself in the next couple of weeks. And these methods are implemented in car1. You can create an instance of car1 again by selecting the default constructor. In addition to the red icon in the object bench, the constructor also creates a graphical representation of the car, which is displayed on the graphics window. By right-clicking on the icon, you can see the same methods, move car and turn car. For now, you can treat these methods as black boxes using the idea of abstraction. If you select move car and enter 200, this time the car is actually moving forward. Let's do this again by selecting move car with minus 100, and the car moved backward. If you try the turn car method and enter 90, good, the car actually turned 90 degrees. Let's use turn car again to turn the car back to the original position by turning it 270 degrees. Well, you have not equipped with all the tools to implement move car and turn car in such a way yet, but you should be able to do this in a couple of weeks.